This is the video on Chapter 5.2, the Part 2, Conservation of Energy. Now, you have learned the energy conversion. You have learned many different energy conversion processes in the last video. Actually, for scientists, they found that for any energy conversion, the total amount of energy before this conversion will be equal to the total amount of energy after the energy conversion. They found that as the amounts before and after this conversion, they are the same. So we call that energy is conserved. 能量守恒. Energy is always conserved. Later on, the scientists found that in this universe, the amounts of energy is actually the same at every moment and every time. The energy cannot be created or destroyed. They can only be converted from one form to another form. This is called the law of conservation of energy. Now, I will use the following example to show you how scientists make use of the law of conservation of energy. Now, I'm taking a ball here. I put a blue line here to indicate this is a ground. And if I move this ball to a higher position, actually it will gain potential energy. This is already mentioned in the first video I delivered here. The amounts of potential energy, or more accurately, I should say, the amount of gravitational potential energy depends on the height of the object. It will move any object upwards, it will gain potential energy. Actually, the amount, how many joule here, you would learn how to calculate it in Form 4 physics. Now, here I just let some of the numbers here for better illustration. Now, this is one piece of fact I need to recap for all of you. You should learn this in the first part in the video about energy. Now, I'm having the following example. Let's say I have a ball. I'm going to release it. 就咁放手, release it. Of course, the ball will drop to the ground. Now, what happens to the ball? It drops to the ground. So you see that the position is already changed. It drops from a higher position to a lower position. So the potential energy of the ball will become smaller. Let's say we have 100 joule potential energy when the ball is at 1 meter height from ground. Now it is located at 0.5 meter above the ground. So potential energy will be half of before. It will be 50 joule here. So I want you to think about the following question. Originally, we have 100 joule potential energy. Now the ball dropped to this position. The potential energy here will be 50 joule. So where are the other 50 joule of energy? Where are they? 嗰50 joule energy 去咗邊? Where are they? So from the last Google form, from the video, you know that if you drop the ball from a certain position, actually it starts moving and it moves faster and faster. Actually, there is one energy conversion occurring here. Some of the potential energy stored in the ball, some of the energy stored, I should not say state of the ball, I should say stay. Sorry, here is a typo here. Stay stored in the ball is converted to the kinetic energy of the moving ball. Actually, it moves faster and faster. It gains 50 joule of kinetic energy. Now here is the location of the energy. The total amount of energy here is still equal to 100. Why? Because scientists found that conservation of energy. You have 100 joule of potential energy here. No matter how you change it, the total amount of energy will equal to 100. Just 50 joule of the potential energy, they are converted to kinetic energy. This is one example of energy conversion, and we make use of the law of conservation of energy. And not to mention, actually, if you're smart enough, you figure out at the beginning, and exactly at the moment when we release the ball, The ball is not moving at that particular time moment. The kinetic energy of the ball is 0 joule. Now I put the list here for better illustration. Now I'm going to drop the ball to the ground, exactly touching the ground. So when the ball reaches the ground, the potential energy here will be 0 joule. Now actually, I should make a remark here. Actually, if you study physics, this is not very accurate. But for Form 1 level, you treat it as 0 joule potential energy here. Why? It's because it is already placed on the ground. It is already touching the ground. So I would say it is 0 meter above the ground. So I put a number here, 0 joule potential energy. So where are these potential energy? Originally, we have 100 joule potential energy. Where are they? They will be converted to the kinetic energy. All of the 100 joule potential energy will be converted to kinetic energy. So at the moment, just before it touches the ground, it has 100 joule kinetic energy. It's still moving downwards. Now I repeat, just before hitting the ground, the kinetic energy, the amount of kinetic energy should be 100 joule. Now let's say I call Thanos. He used a time stone to reverse the time and see what happens here. Now, if the time is being reversed, the ball will be going upwards with 100 joule kinetic energy. 時光倒流的話，咁即係個波由地下彈翻上去，啱啱彈上去嗰刻，應該佢手上、佢身上100 joule kinetic energy. Now this is the case. So when the ball goes up, you know what happened. It goes up, it goes up, it goes up. That means it is having more and more potential energy. And where are these potential energy coming from? They are actually coming from the kinetic energy. So the ball goes up, it moves slower, slower, and slower. At maximum height, it will have 100 joule potential energy. All of the kinetic energy, it will be converted to potential energy. So at most, if all of the kinetic energy is being converted to potential energy, it will gain 100 joule potential energy again, and the ball reaches 1 meter above the ground. So for short summary, what have we discussed just now? First, number one, the amount of gravitational potential energy depends on the height of the object. So I put the numbers here. If it is exactly put on the ground, 0 joule potential energy. 1 meter above ground, 100 joule potential energy. Second thing, number two, if the ball is falling, the potential energy stored will be converted to kinetic energy. The ball will move faster and faster as there are more and more kinetic energy gained by the ball. Number three, if I reverse the time, imagine a ball is going upwards on the ground, from the ground, I should say, from ground, going upwards with 100 joule kinetic energy. Then the ball will have the energy conversion. The kinetic energy will go back and be converted, I should say, the kinetic energy is being converted into potential energy. So you know what will happen if the ball is shooting upwards with 100 joule kinetic energy. However, in a daily life, you know that things are not so simple. Now I'm going to play this video and observe what happened here. Easy, simple, right? What have you found? Very interesting fact. Okay, the ball does not bounce back to the same height which it was released. At release here, the ball seems that it will never go to the original height. And the ball moves slower, and eventually you know that the ball will stop moving. Is it the problem of law of conservation of energy? Why the ball moves slower and slower? Why the ball cannot move back to the original height? Is the energy destroyed, or there's something else happening here? Now, I need to go back and have a very detailed discussion with all of you. Now, this part is a little bit complicated. You will learn more if you study physics in Form 4. Now, try to use simple examples to illustrate what's happening to the ping pong ball, why it cannot go back to original heights, and it moves slower and slower. Okay, go back to this picture. The ball is dropped from 1 meter to the ground. Actually, there's something happens when the ball hits the ground. Before it rebounds, before it moves upwards, there's something happens. So from the video, you know that you hear something. Back. Yes, that means sound energy is being given out. That some of the kinetic energy actually is being converted to sound energy. So here's some noise. And also when the ball when it touches the ground, there is some contact. So maybe in primary school you know that every contact they will have friction, 有摩擦力. So you know that when you rub your hands like this, there will be some thermal energy being produced. Your hands feel warmer. Now, actually, same as the ping pong ball. When the ball touches the ground, some of the energy will be converted. Some kinetic energy will convert to thermal energy. They have friction. So, the problem is here. There must be some sound energy and thermal energy given out. What's the amount? What are the amounts of these energy? I don't know. Actually, I don't know. Even if I study physics, I don't know. But I put some numbers here. Let's say there's 7 joule of sound energy given out and 3 joule of thermal energy is given out. That means the ball is not carrying 100 joule of kinetic energy anymore. It will be 90 joule. Some of them is converted to thermal energy. Some of them is converted to sound energy. So just before the ball rebound, 佢反彈之前嘅嗰一刻， some energy is being converted to other form and then released to the environment. They are gone to the environment, not stored in the ball, not carried by the ball anymore. So when the ball rebounds, it is only carrying 90 joule of the kinetic energy. Okay, so it goes up. Same thing happen again. It will be going to a higher position, so the potential energy will start storing in the ball. And some of the kinetic energy will go to the potential energy. My question is, can the ball rebound to 1 meter high? Why? I want you to think about this first. Pause the video and think about this first. Okay, now I'm going to reveal the answer. Of course not. I show you this slide again. The potential energy, the amounts of potential energy depends on the height of the object. If the object has a higher height, it stores larger amounts of potential energy. So if the kinetic energy of the ball is just 90 joule. When it goes up, when it reaches the maximum height, what will be the what will be the amount of kinetic energy, potential energy here? Now, what do you think about this first? Again, okay, so you know that from daily life, when the ball goes up at the maximum height, it stops at that moment. The kinetic energy will be 0 joule because it's not moving. And the potential energy, what is the potential energy? What is the amount of potential energy in this case? It will be 90 joule. Because all of the kinetic energy, they go to the potential energy. However, if you only have 90 joule potential energy, if you need to reach 1 meter high, you need to have 100 joule potential energy. Now you only have 90 joule. That means at most the ball can go up to 0.9 meter above the ground. So if the process continues, the ball hits the ground again, gives out sound and heat thermal energy. It will lose some of the kinetic energy. They are not destroyed, but they convert to another form. So process repeat. The ball eventually, all the kinetic energy and the potential energy, they will be released as sound and thermal energy to the environment, but not carried by the ball anymore. That's why the ball cannot rebound to the original heights. Now, this is very complicated, I know that. So if you not understand well, so you may leave a comment here and send me an email, or of course, you need to review the video again and again. Lastly, for the bonus part, this is a capture for one of the TV show from mainland China. So I need to explain a little bit. There is someone sitting in a cage in the shape of a ball， 一個好似個波咁樣嘅籠之類嘅嘢。So there is some string holding that ball, and it's going to be released at this position. So the ball will swing to another side. So another side, there will be someone sitting here, waiting for this guy. So the question will be, can they meet each other? Or I should say, can they touch each other? Now think about this first. I will not tell you the answer because you can search it in YouTube. So I will also post a link in the description here. You may search this one, okay? You may search this one to know what will be the answer. All right. So this ends the part about law of conservation of energy. Thank you, all of you. So please have a review. So we'll see you in the next video.